Okay, let's just, once you get out your graphic calculators, and let's see what we can do here. All right, so what do we do with a problem like this? They're asking us to, they give us four-order pairs. They want us to find the constant for the cubic polynomial that passes through these points. And notice, this is good news, they want it written in standard form. Why is that such good news? There you go, yeah, because if we do regression, that's how the calculator gives it to us, in standard form. So all we have to do with this, then, is just go where? Stat, edit, and that's where we're going to put all those ordered pairs, right? X values, Y values. And what do we got? -8 for our X values. -8, 1, 5, 13, 0, 20. There. Okay, now what? Once I get the data in there, what do I do? Stat, calc menu, and then 6, cubic regression. Okay, good. And then all I need is that. Okay, so they wanted to know, in this case, what the constant was. Well, the constant is, and they wanted to round it to 4 decimal places. Well, there it is, right there.
What if it wanted it in a fraction?
They don't. Yeah, the graphing calculator one, I won't ask for a fraction. So that's what they're looking for. Actually, it's D on here, but I mean C for the constant, right? That makes sense. 3968. Okay. Make sense?
Yep.
All right. Okay, next one. Long division. Okay, this says if we divide this quartic polynomial by this quadratic polynomial, if the remainder is written in the form, so we're looking for the remainder after we're done with all the division. If the remainder is written in the form ax plus b, they want to know what's the value of b. Okay? Thanks, sir. Kelsey. Yeah, Kelsey. Okay, so now can we use synthetic division on this one? Can't do it, right? Because the denominator is quadratic, it's not linear, so we got to use long division. Okay, so that's all right, we can do that. Now, the numerator goes inside the division bracket, correct? What are the terms I need to put in there? Plus, careful. Remember, with long division, what do I have to do? Got to have a 0 x cubed, don't I? Because there's no x cubed term, I have to add a 0 coefficient because I need columns for each power of x, don't I? So plus 0 x cubed plus 6x squared plus 4x plus 2. And then we'll see how many times x squared plus 5x plus 2 goes into that. Okay, so what's the first term in the polynomial part of my answer? X squared times what is 4x to the 4th? In other words,
3x squared.
Yeah. In other words, if I just said 4x to the 4th divided by x squared, well, x to the 4th over x squared is just x squared, right? Either way you want to think about it. Okay, so if I distribute them, so if I distribute the 4x squared all the way through, I get what? 4x squared times x squared is my 4x to the 4th, right? It has to be. 4x squared times 5x. Okay, 20x cubed and 4x squared times 2. Okay, and we're going to subtract, and I would strongly urge you to write it this way, minus the quantity, so you remember that you're subtracting each term from the term above it. So these guys cancel, right? 0x cubed minus 20x cubed. Hey, can I get you? I get a couple people that are maybe kind of sidetracked here. Thanks. 0x cubed minus 20x cubed is how many x cubes? Good. Negative 20. 6x squared minus 8x squared. And then I'll bring the other terms down because I'm just subtracting 0 from them. Okay, we start over.
Oh, great.
So x squared goes into negative 20x cubed how many times? Negative 20x. X squared times what is negative 20x cubed? Negative 20x. Good. So if we once again distribute, right? I get what? Negative 20x cubed. Negative 20x times positive 5x.
Negative 100x squared.
And then negative 20x times positive 2. Good. Subtract that whole thing. So negative 20x cubed minus negative 20x cubed cancels. Negative 2x squared minus negative 100x squared. Good, so we're adding the 100, so we're 98. 4x minus negative 40x. And then we bring the 2 down. Okay, last time through here. X squared times what is 98x squared?
98.
Okay. So if I distribute, I get 98x squared. 98 times 5 would be what? 492? Is that right? 490. There you go. 98 times 2, 196. Okay, and if I subtract that whole thing, x squareds cancel. 44x minus 490x is negative 446.
Yeah.
And then 2 minus 196 minus 194. Right? And that's our remainder. Now they wanted us to find, if you look back up here, they want us to find the value, if our remainder looks like this. If it's written as a linear expression, yeah, they want the constant, right? It's in the form ax plus b and they want b, then isn't that right there? Okay. Make sense? That's a long problem, but
Yeah, I don't like that one.
the long division is long, true to form, but it's not horrible. Okay, find the greatest real zero of the function. Now, if we have our graphing calculators, what are we probably going to do with this? Sure, why not? Now, we could, what's our other option here? It's really, with a calculator, it's pretty simple. We could do quadratic formula too. Those are two pretty good options. If we use quadratic formula, what's A, what's B, what's C? Okay, A is 10, B is 7, C is negative 2. So the quadratic formula is going to give us negative B plus or minus square root B squared minus 4 times 10 times negative 2 all over 2a would be 20, right? I could evaluate that pretty easily in my calculator, but then what goes out front? What's equal to all that stuff this time?
X squared.
X squared, sure. Okay, because it's a x to the fourth and an x squared term instead of an x squared and an x from chapter 5. So if we do that, let's take a quick look at how that turns out. Where's my calculator? Okay, so all we'd have to do then, if we use the quadratic formula, and that's fine, we would just have the quantity, -7 plus square root 49 minus 4 times 10 times -2. Close, get out of the radical, close the numerator, close the whole numerator, and divide by 20. So one answer we get is x squared equals that, right? We want the greatest real zero. So if I square root, if I get that answer, x squared equals this, there's one possibility. Yes. 2, 1, 7, 8, 9, blah, blah, blah. I have to square root, right? And I get a plus or minus answer. So one of my answers would be, if I square root that previous answer, I get that. 0.4, 6, 6, 7, 8, etc. Okay, now how would I get the other one? By -1, right? So I get plus or minus that. Now, what if I want to go back and get? Now, I use the plus sign, right?
Yeah.
But I could go back and overwrite that. If I go up and grab that expression with the square root or the quadratic formula expression, I could just go back and change that minus a plus sign to a minus sign. Oops. Right there. Make that a minus sign. And my other answer is negative. So if I square root it, am I going to get a real answer?
No.
No. So then this is my answer. Whoops. Actually, that's my answer right there, isn't it? 0.4. We want it how many places? 3. So it'd be 0.467. Okay. Make sense? Okay. Now I could also, if I wanted to, oops. The other alternative would be if I just went up to y equals and graphed it. 10x to the 4th plus 7x squared. Oops. Yeah, fine. Oh, let's just do 4th. 10x to the 4th plus, there finally, plus 7x squared minus 2. Did I do that right? Finally? Yeah. So if I graph that, how do I probably want to start off with the screen? What do I do to graph this?
I zoom.
Zoom 6 to start with to see if we can see it. And it looks like we can.
Not very well.
Not real well, so I want to zoom in a little bit. How about if I let the window go from -1 to +1, so I can spread that out a little bit, see it better. So the window, x-min, -1, x-max, +1. And remember that the x-intercepts are the real zeros. Imaginary zeros aren't x-intercepts, but the real zeros correspond to x-intercepts. So I can go find this guy right there. Second calc, what do I want? If I'm looking for the x-intercepts? 0, yeah. Same thing as a 0, isn't it? So we'll look for 0, hit number 2. And that's good left boundary, that'll work. There's my right boundary. And there's guess. Okay, it tells me the same thing, 0.467.
That's easier.
Probably, yeah. It could be, I think it is easier. The one the one problem you might have to deal with using the graph would be, what if the graph didn't show up real well at first? Then you gotta mess with the window until you can see it. So I don't know. I mean, they're both, take your pick. All right. Okay, what about this? When the polynomials are multiplied, what is the leading coefficient? Now that's a lot of work to expand those polynomials out, isn't it? If I were gonna multiply these out and get an answer, I would have to distribute all three of these terms over all four of those terms, add up all the like terms, right? Is there a shortcut here?
I hope so.
Can anybody think of a way we could maybe cut some corners?
Divide it by x cubed.
It wants to know what's the leading coefficient. Now, what does it mean to be the leading coefficient? Yeah, the leading coefficient is just the coefficient of the biggest power of x. Now, if I were to distribute all this stuff through, what is going to be the biggest power of x?
12. 24.
Okay, x to the 12 times x to the 12. If I take the biggest power of x, the biggest power of x over here, times the biggest power of x right there, those are the two terms that are going to get multiplied together to make the biggest power of x, right? All the other ones will be smaller. So when I do that part of the distribution, I get, 2 times 3 is 6, x to the 24 plus a whole bunch of smaller stuff. So what's the leading coefficient?
6x.
No. 6. Leading coefficient is just the number in front of the x, right? So a coefficient. We would just put in 6. Okay? All right. Okay, using finite differences, determine the polynomial function that matches the following data. Okay. And then use that to predict the value of the function when x equals 8.27. Okay, so this is a little bit of a process too. How do we do this? How do we use finite differences again? Yeah, this is that one where we have to make that big, the difference tree, right? This whole thing. And why do we need this? What's the point of doing this difference tree? Yeah, we have to know what kind of regression to do, right? We have to know what kind of, what type of polynomial. So if we do that, how much is the x changing? Well, 30 minus 131 is what, negative 101? 1 minus 30, negative 29, negative 4 minus 1. Whoops. Negative 5, right? Yeah, it's so easy to make a mistake on this. Negative 9 minus negative 4. Okay, so I'm adding then if I subtract a negative, right? Negative 14 plus 9. 5 minus negative 14. 15, good, and then 96 minus 5. Okay? All right, let's go again. Negative 29 minus negative 101. Is that 72? Negative 5 minus negative 29, so 25? 24. 24, whoops, you're right. Zero, 24, 72. Yeah, now it's starting to look a little symmetrical, isn't it? So I bet you we're about there. 24 minus 72, what is that? Minus 48? And then finally we got it, didn't we? So we got it, right? Now, how many times did that take? Let's see.
4.
Let's count. We started here, so we went 1, 2, 3, 4. The fourth order differences were the ones that worked. So what's the degree of the polynomial? 4. Okay. So if the degree of the polynomial is 4, how many ordered pairs do we need to use then?
4.
5. One more than the degree, right? So we can just pick, let's pick easy ones. How about if we pick the smallest ones right in here? These look small. Let's just pick those. Okay? Not that it matters. So we'll pull up the calculator. We'll do our regression. But don't lose sight of what we're trying to do with this one either. We're trying to use a mathematical model. We want to know what is the value of the polynomial when x is 8.27, right? So when we do our regression here, let's make sure we store it as a y variable. Store it as y1 so we can graph this thing and then plug in 8.27, right? Okay, so let's go in and go stat, edit. We got to put in these 5 ordered pairs. So the x values just go from -1 to 3 in order. Okay. Y values 1, -4, 14 and 5. Okay? So we got them in there. Now what? Got it. Okay, so we got to go stat, calculate menu, and then we're going to go to the very bottom. Remember, these go in order. Linear is first degree, quadratic is second degree, cubic is third degree, quartic is fourth degree. So we're going to choose 7. We want to go down and store the regression equation as y1. We have a shortcut. We can always go variables, y variables, function y1, like we used to a long time ago. Or we can take a shortcut, alpha F4, then we get right to the y menu. Choose y1, and then we'll just calculate. Okay. Now, well, this one worked out really well. What we could actually even do, because this worked out so well, these are all integers, and we could even just write this thing down if we wanted. I mean, that's fine. We could write down the quartic polynomial and then plug in this value of x in our calculator. That's fine. But we graphed it. That's nice. If we want to get 8.27, and we want to find the value of the function when x equals 8.27, then 8.27 has to be in our window. Well, it is, because remember we did zoom 6 last time. Oh, no, it's not actually. We changed it, didn't we? So if we go zoom 6, I don't know if we'll see this thing or not. There it is. Okay, there's the function. It's off the screen. That's okay. It doesn't really matter. As long as the x value is included in the window, we can ask the calculator for the y value that goes with it. So then we'll just go second. Any questions so far on that? You've done this a bunch, but there's a lot to do. Many questions about what we do, about this second part, about how we find the y value when x is 8.27. Everybody can do that? I mean, we've done it all year, but we don't do it very often. Okay? So we'll go second, calc, value, once the x value, 8.27, as long as that's between x min and x max, it'll tell me the answer. 3449.1673. They want it to, how many places?
3, 4.
Well, there it is. 3449.1673.
It's a big number.
To 4 places. Yeah. Okay? Make sense? Okay. All right. Okay, calculate the product of the three binomials. Now, what do we do with this? There's really nothing. Our calculators don't really help us with this.
No, you just multiply 2 and then distribute them. That's
Yeah,
one.
we have to just FOIL out 2 of them and then distribute the third. Do we want to do this one?
No.
Seems like this is one probably that we've done this enough. If I'm happy to do it, but we did this on one of the other reviews too. So I could just, for example, FOIL out the second 2, get an answer, collect like terms. It's going to be a trinomial. I'm going to get 30x squared plus 20, so plus 56x plus 24 when I add all that stuff up, right? Then I'll just distribute the 8x all the way through, distribute the 4 all the way through, add up the like terms, and whatever the x's add up to, I want the number of x's, the coefficient of x. Okay? Okay, what about this? Evaluate the polynomial function for the given value of x. What do we do with that? Plug it in, right? No big deal. Just plug in x equals 4. When we're evaluating, we're trying to get the value means number. Plugging the number in and finding the value of the function. So put the 4 in. On the calculator, I could graph it if I want to. Remember, I could also do this. I could also say, I could put in that, let's put in x equals 4. So 4 store is x. So now x is 4. If I just type in this expression and hit enter, it'll put that 4 in there. So I could go 9x to the 4th plus 5x cubed
How did you do the 4 to the x?
minus, I said 4 store x,
Okay.
right? You put in a 4, then you hit the store button, and then x. It'll store that value as the x variable. Minus x minus 2. If I hit enter, there it is. That's the value. Okay, it put in x equals 4 and it calculated all this stuff for me. Okay. And I could just I could just substitute a 4 for all those x's too. Either way, doesn't matter. Okay, what about this? Let's see. Greatest zeros. What would we do? Yeah, we could graph it. That's fine. We could just put this in as y1 and find the x-intercepts. Or we could, yeah, let's see. We're not going to be able to do quadratic formula this time, though, because if I pull it, I can factor an x out, then I'm left with a cubic. This is going to be one where we're going to have to graph it. Okay? And look for this, the x-intercepts are the real zeros. So this is one that we couldn't have done with our fancy techniques we learned in chapter 6. That's one we couldn't have factored. This is one we have to use a calculator on. So put it in as y1, get the window so you can see the x-intercepts. The greatest zero corresponds to which x-intercept on the graph? If I can see all the x-intercepts up there, which one's going to be the greatest zero? What do you mean by greatest? What does that mean on the graph? Highest meaning in which direction? To the right. Yeah, furthest right. Greatest zero would be furthest to the right. Least zero would be the one that's furthest to the left. Okay? Make sense?
Since we stored the scores, it's still in there like that?
It is, but it won't matter. It doesn't matter. I mean, there's always some random value of x in there that you don't even know what it is. The only time you ever care is when you do this. If I plug in an expression and then hit enter, it evaluates the expression for me.
So it doesn't matter what you want to graph.
It doesn't make any difference when you're graphing stuff or doing any other thing. It's only when you want to do something like this that it matters. So if I wanted to do something like this again, I would have to be sure to just store a different value of x in there. Okay, almost there. Real simple one. If these polynomials are added together, what's the leading coefficient? So now if I'm adding polynomials, just adding like terms, right?
So it'd be like 20.
The leading coefficient is just going to be the power of the number in front of the biggest power of x. Well, it looks like,
16 is the biggest.
yeah, there you go. Yeah, it looks like the biggest power of x is x to the 18th, right? And it looks like I've got two of those. I've got one there and one there. When I add all these terms up, then I'm going to get 4x to the 18th plus 12x to the 18th is 16 x to the 18th plus small stuff. And all I care about is the leading coefficient, right? So the leading coefficient then would just be 16. Okay? Okay, what if, now this is, we essentially did this one, right? This is 4x plus 9 cubed. What's the coefficient of x if I expand that out? I got two options here. Kind of the long way would be if I wrote this as, whoops, yeah, if I just wrote this, and this will work. It's not really the best, most efficient way, but it works. If I just wrote it like this. Right? And then just FOILed out two of those and distributed the other one. Now there is a shortcut. We know that a plus b cubed, we have a pattern for that. That's, remember this one? That's a cubed plus 3. Remember the a's step down and the b's step up? We have that pattern. That'd probably be quicker. Because then the a, every place I have an a, I would just put in a 4x. Every place I have a b, I would just plug in a 9 into that expression. But they both work. They both work. I'm just trying to expand this thing out. And then when all the dust settles, we want to know, when I've added up all the like terms, how many x squareds do we have? Okay? And last one. Last one. When a polynomial function of least degree, etc., etc. Remember, this just means easiest polynomial. The polynomial we get if we multiply out all these factors. Okay, so here are my zeros. X equals 3, x equals 1, and x equals 3i. So how do I build a simple polynomial from those factors? What do I have to do? No, not really. You might be thinking the right thing, but you're not saying it. Yeah, I've got to turn those into factors, right? And then I'll just expand out or multiply out all the factors. So from this guy right here, I get the factor x minus 3. From that one, I get x minus 1. Now, what about from this guy? Okay, x minus 3i. All right.
Plus 3i.
Yeah, I've got to have another one there, don't I? They don't give it to us, but we know that the i's have to come in pairs. So with that, I must have a minus 3i. Right? Those have to come in pairs. Does that make sense? So they didn't give us all of them. If they give us one, it implies the other. We have to write that one down also. Now, when I FOIL these out, this is my answer, right? That's the polynomial, but they want us to expand this thing out, right? Which two should I multiply first? Yeah, the conjugates, right? If I FOIL those out, I get x squared plus 3ix minus 3ix, right? The x terms cancel. And then I get minus 9 I squared. But what's I squared? Negative 1. So that just becomes x squared plus 9. And you always know you're going to get an x squared plus something when you multiply these out instead of x squared minus. Okay, and then the other two, I guess if I FOIL those out, what do I get? X squared minus x minus 3x, so minus 4x plus 3. Now all I've got to do is just distribute and I'm done. So if I distribute the x squared all the way through, I just get x to the fourth minus 4x cubed plus 3x squared. Distribute the 9 all the way through. Okay, and then add all those up. And what did they ask for? I forgot. They want to know what's the coefficient of x. So the coefficient of x is negative 36. Okay? And that's it. Make sense?
Yep.